In the previous video, we pulled some logic out of our initializer and into its own closure. As we did, we explored function value types. In this video, we're going to take a look at one of the most useful features in Swift, extensions. They offer us the ability to extend any class, enum, or protocol, even if the source code is not available to us. If you recall the rules for Game of Life, the next state a cell will move to rests heavily on the current states of its neighboring cells. So we need a way to identify the surrounding cells along with their states. I'll paste in a function and break it down line by line. This cellNeighbors function takes a cell and checks it against every cell on the board to find its 8 matching neighbors. At the top of our function, we create an empty array where we'll put our neighboring cell matches. We'll ultimately use this as our return object. Next, we loop through all of the items in our cell array, splitting each against our given cell's x-chord and y-chord, subtracting the difference, and saving the absolute value into 2 separate variables. Now, we could easily pass our 2 separate variables as a tuple into a switch statement, and in a real application, I just might do that. But this is a good opportunity to put Swift2's new if case statement to work. We define an if case much like a switch. In this instance, we'll check our 2 values as a tuple to see if we have a matching neighbor. Matches are represented by tuples with the value of 1, 1, 1, 0, or 0, 1. So using Swift's pattern matching capabilities, we can check a single if case for a tuple containing 2 separate range operators that range from 0 to 1. Of course, there's a problem with this. Our range operators are capable of matching a value of 0, 0, which is not what we want. Fortunately, Swift2 has given us the ability to filter many different operations, including this one. So we'll add a filter that guarantees we'll never get a match of 0, 0. Then we'll add an else statement that simply returns false for all other cases. This Boolean represents whether the given item and the current cell items are neighbors. If they are indeed neighbors, we'll append them to our neighbors array, which we'll ultimately use as our return value. This is a lot of work for one function, and it really misses the mark when it comes to functional programming. So we'll split this into 2 separate functions. For instance, this evaluation stage would work nicely as its own function. Let's create a new function named CellsAreNeighbors. Give it 2 parameters, one named side A of type cell, and the other named side B of type cell, and it returns a bool. Let's move our if case logic into this function and update our cases. Now, in our cellNeighbors function, let's replace our check variable's default value with a call to our new function since it returns a bool value. This is much better. We've simplified our function by breaking it into smaller pieces, but we can simplify it further. If you think about it, all our function is actually doing is filtering out which cells are neighbors. This may be a good use case for an extension method. Extensions allow us to open up existing classes and add new methods and computed properties to them, all while giving our newly added code a native feel. Let's open up a playground and add some functionality to Swift string type. It would be nice to be able to get the length of a string without having to use characters.count. We can add this functionality by declaring an extension to string with one computed property. We can then use our new string extension like any other native feature. We can also extend types like double just as easily. This extension extends the double type to immediately convert liquid measurements from a given unit to cups. It doesn't stop there. We can also extend both enums and protocols if the needs arise. You can find more examples and discussion on extensions by checking out this video's resource page. Let's create a utility file for a quick extension experiment by pressing Command-N and choosing iOS, Source, and then Swift File. Name your new file Utility and click Next. We're going to extend Swift's array type to handle our filtering dilemma. We'll define an extension by using the keyword extension followed by the type being extended. I'll paste in the functionality and break it down line by line. Here, we are defining a new function on array called getNeighbors. GetNeighbors takes a function and returns an array of cell. The parameter predicate represents a function that will evaluate the given element and return a bool. Finally, our extension returns an array of neighboring cells. Back in our live class, we can replace our logic with one simple line. This certainly has a more functional feel, but I'm not convinced that extending array in this manner makes sense. We shouldn't add blanket functionality to a given type for one edge case. If we're going to extend an entire type, we should make sure that our extension of that type makes sense universally. In this video, we explored extensions and wrote a neat little extension of our own. In the next video, we'll explore generics and utilize them to re-implement our extension to be more flexible.